Okay, let's have a look at how soaps dissolve fats and oils and greases. Now, fats and oils and greases are notoriously difficult to remove from objects. They're very difficult to dissolve because they don't readily dissolve in our most common solvent, that being water. So we need another mechanism to help with this process. And we use what's called a surfactant molecule, or the salt of a carboxylic acid, to do this work for us. Now, I've drawn a molecule on here that is a sodium stearate molecule, a very common soap. And we notice two things about it. First of all, we've got a long carbon chain. In this case, it's got 17 carbons on there. And this particular part of the molecule will be non-polar. It won't dissolve in water. We also call this a hydrophobic part of the molecule as well. And on the right-hand side, because we've got an ionic bond between our oxygen here and our sodium, we form a polar part of the molecule. So within the one sodium stearate molecule, we have a non-polar region and a polar region. Now, something interesting happens when we put this particular molecule into water. So we add water to it, and instantly our molecule dissociates. So our sodium is given off, and that leaves us with a negatively charged group here with our long non-polar chain attached to our C double bond O minus group. So let's expand this particular molecule out. So on the left-hand side, we've got our polar chain, which we've already said is our chain which is non-polar, we've already said it's hydrophobic. It doesn't want to interact with water. On the other hand, we have our polar component of our molecule, which we've said is hydrophilic. Now, two things happen with this particular molecule. On the right-hand side, our polar section will interact with water molecules, so we get one of two things happening. The slight positive charge on the hydrogen of our water can interact with the negative charge, as we've indicated here. We can also get a slight interaction between a positive charge and the double bonded oxygen, because that's got a slight negative charge as well. So in effect, we form hydrogen bonding in this section, and this section effectively dissolves in water. On the other hand, our non-polar region will not interact with the water. In this case, this section will be hydrophobic, and we won't get any dissolving in the water. However, if we bring this whole molecule into contact with an oil molecule, or a grease or a fat, we get an interaction between the non-polar region and our oils and fats. And we do this through the action of dispersion forces. So we get the interaction between our non-polar region and the non-polar section of the non-polar oil molecules. So effectively we form weak bonds here. Now they're weak bonds, but if we get enough of them, we get a strong interaction between this non-polar part of the molecule and our oil or fat molecule. Eventually, we can get multiple molecules interacting with the oil molecule to build up a large amount of bonds or dispersion bonds between the molecules. And we've represented it in this particular diagram. So what I've done is take this section, and we call that a polar head. It's negatively charged. And our non-polar region we call a non-polar tail. And what we find with our oil or fat molecule is that we get bonding to the non-polar tail, and we have our polar regions exposed to the surrounding water molecules. And this forms what's called a micelle, where our oil is surrounded by a series of our surfactant molecules, and on the inside is our non-polar region, and on the outside is our polar region. So as we expose our oil molecule to surfactant molecules, such as the one up here, the oil droplet or the fat droplet is surrounded by this system and effectively breaks up into smaller pieces. So if we were to wash a pot that's very greasy, we might have the one large oil or fat deposit, as we add the surfactant to it, it breaks up into smaller micelles such as this one. And then if we add water to the system, the interaction between the negatively charged head and the water allows us to wash that small droplet of oil, or the micelle, away. And that's how we clean our pots of fats and greases and oils. It's also how we clean our hands with soap. We break the big molecules down into much, much smaller molecules, which can then be washed away through the interaction of the negative charge here with the water.